goes over the basic parallelogram properties. So these aren't special parallelograms, these are just basic parallelograms where we know that opposite sides are congruent, opposite sides are parallel, that opposite angles are congruent, and adjacent angles are supplementary, and our diagonals bisect each other. So all of those basic parallelogram properties. So on one, our missing variables would be A and B. So I have A here and B here. What is A going to equal? 9, and B would equal 11. Great. Then it gets a little more challenging on 2. We have X and Y, where we have X plus 2. What would X plus 2 be equal to? 4. So then I subtract 2 and I get X equals 2. On my Y equals, I have Y minus 5, which would be equal to 12. So I'd have Y minus 5 is equal to 12. 17.
Yeah.
And Y equals 17. Then on our third example, we have a mixture of sides and angles. So for X, 3X plus 4 would equal?
Well, would equal 16.
Would equal 16. Well, hold on, it's not going to be, yeah, and then it'll be 12. So 3X plus 4, this side is equal to this side. Subtract 4, 3X equals 12, X equals 4. And what about Y subtract 60? What is that equal to? 56. Yeah, these opposite sides or opposite angles are congruent. So Y subtract 60 equals 56. Add 60 and Y equals 116. 106, 116. Which, did I do something wrong there? Okay.
Yeah, pretty good.
106 would have been 50. I'm good. Then we get to 4. So definitely they get progressively kind of adding more properties and a little more challenging. I think that's a G. 8G subtract 3. What would that be equivalent to? 25. Yep. Opposite sides congruent. Add 3. So 8G equals 28. Divide by 8, that's not going to go in evenly, but I can reduce it to 14/4. And 3.5 would be fine too, yeah. Then we get to the angles, and this is, these are adjacent angles, not opposite angles, which means I'm not going to have F plus 30 equal to 72. What's true about these angles? They're equal to 180. So I can either set up an equation where I have the F plus 30 and then plus 72 equals 180. Or if I know that this is 72, then how much must this angle measurement be where F is? 108. Yeah, these are supplementary. So another option is figure out what this angle is. So then I know F plus 30 equals 108. And I just subtract 30. And what would F equal? 78. Then we get to our diagonals. So parallelogram property is that our diagonals bisect each other, meaning that at this point, it's cutting this diagonal into 2 equal parts. So I know that 9 equals 2n subtract 1, or 2n equals 10. And n equals 5. And then I also know that it's cutting this diagonal into equal parts. So in a general parallelogram, they're not all the same length, but these two are the same length and these two are the same length. So then I know 3m equals m plus 8, or 2m equals 8 and m equals 4. Same idea here. So I know that this is being cut into equal parts. 3j equals 5j subtract 9. Or negative 2j equals negative 9. And j equals 9/2 or 4.5. and that k plus 10 equals 6k, or 10 equals 5k, and k equals 2. Okay, diagonals are being bisected, opposites are congruent, opposite angles, opposite sides, adjacent angles are supplementary. That's like like I said yesterday, like the big mom of all of these, or the grandma of all of these special parallelograms, is our general parallelogram. Within that, there are specific parallelograms or special parallelograms. So if you want to find your notes too from yesterday, I'm just going to kind of talk through the first two we looked at. And then we're going to look at squares, another special type of parallelogram. So this is notes number 2 in the Unit 5 packet. In the notes packet. So you have your homework packet and your notes packet. You want the notes packet. Okay, so we talked about rectangles yesterday. All of the parallelogram properties are still true. And then special to our rectangle is that the diagonals are congruent. So we end up with 4 equal lengths here, which gives us this property. If I have an isosceles triangle, then my angles are the same, and same here. So that's going to allow me to find all sorts of angles. Then we talked about our rhombus, and our rhombus is a parallelogram where all 4 outer sides are the same. And when that happens, our diagonals are perpendicular. So that's one piece. And this is an important one, it bisects the opposite angles. So it's breaking these angles into equal parts. Okay, that was our rhombus. And we're going to get practice with both of those. Actually, let's do the practice first, and then we'll go back and do the square. So if you flip this over, there are some examples at the bottom here. And so when I look at my rectangle, I know that I have all my parallelogram properties. Now, the thing that's special to rectangles is that all of my diagonals are the same length. So I'm going to at least mark that, and then if I need to mark more, I will. And so it tells me, the pieces it tells me is that AB, which is here, A to B is this length, is 24. That A to C, so this whole length from A to C, from here to here, that's 34. And then it's asking me to find EB, which is here, and DC, which is here. Let's start with the easier of those two. Tell me, what does DC equal? 24. DC equals 24 because opposite sides, we know that they're congruent. So if this side is 24, this side is 24. Now this is the tricky piece with rectangles. I have to know that the new property is that they're all the same, because it gave me this diagonal AC, and then it asked me to find the half length on the other diagonal. Well, it doesn't matter which diagonal I was given. If I know that this whole length is 13, what is each half? 17, and they're all the same. We know the diagonals are congruent in my rectangle. So it doesn't matter that it asked me to find part of the other diagonal, it's still going to be 17 for half the length, because the diagonals are congruent in a rectangle. We're given another rectangle, and in our rectangle, it tells us that JL, so just from here to here, that this length is 38, and that G to K is 56, and it asks us to find HJ and HK. Okay, so it wants us to find those two lengths. Let's start with the easy one. What is HK, or sorry, HJ? 56. Okay, opposite sides are congruent. The more challenging one is here, but again, we know, oh, it's a rectangle, boom, 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 boom. So if this length is 38, then so is the other half of that diagonal, and my diagonals are congruent, so this would be 38, and this would be 38, which means that HK
76.
would be 76. 38 and 38 together, okay? So with our rectangle and rhombus, the special properties about them are always about the diagonals. So with the rectangle, the diagonals are congruent. With the rhombus, the diagonals bisect the angles and are perpendicular in the middle. So if you flip this, and we'll go back to square after we're done, there's a couple using our rhombus properties. And the first one is using, so the other thing that's special about our rhombus is that all of our sides are the same. So all of the four outer sides, it's like a square, but it's not necessarily 90-degree angles, where all four sides are the same. So here it gives me two sides and they're not the opposite sides, but when it's a rhombus, it doesn't matter. All of these four side lengths are the same measurement. So I can find X by setting these two sides equal to each other because all four sides are the same length. So I got to start there. So 9x subtract 13 equals 4x plus 7. I'm just going to write a note. The reason I know that are all sides are congruent. Okay, because remember, we'll have notes again on this assessment. So, and I think this is probably the hardest one out of the last few units in terms of keeping properties straight. So the more you kind of give yourself clarity on why you're doing what you're doing, the better you're going to feel when you look back at these examples. So then solving for x, maybe I subtract 4x. I get 5x subtract 13 equals 7. And then I get 5x equals 20. And x equals 4. Now, then it doesn't ask us for x. It actually asks us for BT, which is a side that didn't even have an X on it to begin with. Well, they're all the same, yeah. They're all the same length. So it doesn't really matter which side I look at. If I plug in 4, whether I plug in 4 here or I plug in 4 here, I should get the same length. When you substitute 4 in for X, what do you get for a side length? I think this one's a little easier to look at. What did you get? 21. Which one did you use?
You get 23.
I get 23, but I was looking at this one. Do you get 23 here too? 36, yeah, 20, 23. So if I substitute in 4 here, I get 4 times 4, 16, plus 7, 23. If I plug in 4, if I were to use here, it would have 9 times 4, which is 36. Subtract 13 is 23. Okay, like I said, it doesn't matter because all my sides are the same. So I have 23, 23, and the side it wants BT would also be 23. Okay, so rhombus, all of my sides are the same. It's blurry. So now here comes the trickier piece with our rhombus. So if I get a rhombus and I'm not even looking at what it's asking me for, I'm going to mark what I know is true, which is all of these sides are the same. We're not going to need that on this one, but I'm marking it. It's a rhombus. I know that's true. I also know that all of these middle angles are 90-degree angles. That's a special rhombus property. Okay, so I'm going to go ahead and mark that. I also know with a rhombus that these angles are split equally. So whatever this angle is the same. Same idea here. And that's going to be true on all of those angles. All of those angles are bisected. Now notice I marked them differently because R and T are the same measurements, so they're split into the same measurements. S and V are the same, so they're split into the same equal parts. Okay, but not all of those angles are exactly the same measurement. So the place where I start here, so now that I've marked it, this is the piece that I can start with. Okay, because I know that angle measurement. I can't set like this equal to that. They're not equal. They're not the same angle. And I don't know what this angle here is, but I do know that 2y plus 10 equals 90 because that's going to one of my 90-degree angles. So I say, okay, 2y plus 10 equals 90. I know that. Or 2y equals 80. Y equals 40. Okay, now that I know what y is, I'm not even going to look at this. I'm just going to kind of show you how you kind of play this game with filling things in. Then this angle here would be what if y is 40? 42. If this angle is 42, then this angle is 42, and this angle is 42, and that angle is 42. Okay, they're all broken up equally. That's one of our rhombus properties. Now, I can find my other angle as well, because for all of these, I have a triangle here, right? When I draw on my diagonals, it gives me these triangles. And so in this triangle, I have 2 out of 3 measurements. I have 42 and I have 90. How many total degrees is inside my triangle?
32.
One, what? What happened? Oh, one, okay, I see what you're doing there. But what total is in my triangle? Somebody said it 180. You said 132 because you added these two together, right? So I have 90 and 42 gives me 132 here, which means this angle is 180 subtract 132. Or how many degrees would this angle be? 48. Yeah. And guess what? If this angle is 48, then this angle is 48, then this angle is 48, then this angle is 48. Okay, so by having one angle, we have this angle, 42, I can find all of those angles. And then I can even, like if it asks me for this whole angle, I just need to add them together. So it might ask me for this whole angle and I'll have to add 48 and 48 together. So now let's go back and see what it asked for. So it says find WSR. So W is here in the middle. W to S to R, that would be this angle right here. I put a dot there. W to S to R, that would be right here. I've already labeled it. 42. And that's kind of how I typically solve these problems. Like I just fill in everything I can. Then I go back and answer the questions because then I pretty much have everything and I'm just filling in the blanks. SRV, so S to R to V. That's this whole angle measurement, S to R to V. So what would that entire angle R be? It would be 96, yeah? Now I'm just adding 48 and 48 together. Whoa, that got right. RWV, from R to W to V. What is that measurement? It's a 90 degree. That's one of our middle angles. Okay.
I'm saying chemistry.
Does it?
Yeah, like if you knew what the
Something is, it
were,
kind
you
of
would
dominoes
get
into
electron,
others.
You would get how many
Mhm.
was there, and then you get how much was the cation, and so on.
Mm-hmm. I wish I could go back to school. I mean, like I could go back to school, but I want to go back to like high school and do like science classes again, you know, or like you know what I really want to take again is history class, because when I was a teenager, I hated social studies. I mean, I hated it, and like I did okay, but I didn't really pay attention. You know, like I studied for the test, crammed all that info in, took the test, it flew out of my brain. But like I want the info now. Like now I want more historical knowledge. You should all pay attention in your social studies, in every class, but like it's a regret of mine. I want to retake them. I want to learn more.
Who's your favorite historical figure?
It's a really hard question, Jaden.
I have a top 10.
Do you?
Yeah, they
You have a
include like Theodore Roosevelt, Jack Dempsey. My favorite is Frederick the Great. He's awesome.
I don't even know who Frederick the Great is.
Well, Frederick the Great, come on, 7 Years' War.
See, I feel like I fit more in the like people I know a lot about would be like more like 60s era type of thing, not way, way back when. That's where I was going with favorite historical figure. You know?
Yeah.
Do you want to know a cool fact about my ancestry? I have to get a 23andMe. That's what I need. But I haven't ever asked. All right, so we have our rectangle and we have our rhombus. And I'll flip back and we're going to talk about the baby of the family. Okay, the square is our baby. And really the square is, you know, it's not maybe necessarily the family that we're used to, because we have parallelogram and we could maybe say their children are the rectangle and rhombus, and then it would be like if rectangle and rhombus then had a baby, it would be square, right? Which, you know, so maybe that's not quite, the family analogy maybe isn't the best one here, okay? But if the rectangle and the rhombus everything got put together, it would create a square, because the square has 4 right angles. Okay, that's coming from our rectangle. And 4 congruent sides. And that's coming from our rhombus. So what happens here is we get some tricky questions with this unit. Like, for example, every square is a rectangle, meaning every square fits all of the rectangle properties. Is every rectangle a square? No. No. So you're going to get questions like that. Is every rectangle a parallelogram? Yes. Is every parallelogram a rectangle?
No.
No. Okay, so you've got to kind of think about which one comes above which. Every square is a rectangle because it has 4 right angles. I wrote that up above. And every square is a rhombus because it has 4 congruent sides. Therefore, every square is a parallelogram, well, because it's a rectangle and it fits in the rhombus properties, and a rectangle and a rhombus, they are both parallelograms. So it kind of umbrellas under the square.
It's such a fun word to say.
Parallelogram, it really is.
Parallelogram.
It's a good one. So I love squares. I love squares because there's really no solving needed. We're going to be able to determine everything here. So our square, it's a rhombus, so it has 4 congruent sides. Our square is a rectangle, so it has 4 right angles. Okay, so that's our beginning piece with our square. Sometimes a square, and in some of the documents it may still, Mr. Roberts, who used to teach here, used to call the square, I don't know how he spelled it, a rhombotangle. I believe it's how, so some of the documents still have that wording in it. I'm not sure if that's how he spelled it though, but it's a rhombus rectangle. Everything that's true for a rhombus, true for a square, everything that's true for a rectangle, true for a square, everything that has been said, at some point this unit will be true for a square because it's the baby, everything's umbrellaed over it. So that means that the diagonals of this square are, sorry, I'm trying to decide what order I want to go in. Okay, the diagonals of the square are congruent because it is a rectangle. So I'm going to draw my diagonals and we'll mark it as we go. So because it is, I'll use 2 tick marks because I used 1 for the outside. Because it is a rectangle, all 4 of these lengths are the same. The diagonals of a square are perpendicular, which means 90-degree angle. Because it is a rhombus, The diagonals of a square are perpendicular, meaning all of these angles in the middle are right angles. No, definitely not gonna have enough space. The diagonals of the square bisect the opposite angles because it is a rhombus. Plus, I'm going to go back over here since I wrote stuff underneath. They still bisect each other because it's a parallelogram. Parallelogram. But that doesn't really matter because we're going to mark them all congruent anyway because it's a rectangle. Okay. So those diagonals are doing all sorts of crazy things. Now, here's what makes a square super easy to solve and super special, because we already can, like, I'm going to know all of the angles looking at this. We know that this is congruent. So we know that these angles have to be the same because it's isosceles. We know that it's perpendicular in the middle, and we know it's bisecting the angles. Now tell me, if I bisect a 90-degree angle, how many degrees would be on each side? 45. So I don't have to do any solving for a square because I know, because a square is a rhombus, that it has cut those angles in half. And so all of these little halves of 90 are 45. It's 45 all the way around, and the middle angle is 90. Okay, that's how my square is broken down. And then if it was like the end of this year in geometry and you saw a rhombus again, you'd even be able to, given one side, basically find any of these measurements, because a 45, 45, 90 triangle is a special type of triangle too. So like squares are just super cool. It's just all there is to it. Now, if I know that I have just one right angle in my parallelogram, then it must be a rectangle. Now it could be a square, but I don't know that it's a square. If I have one right angle, I'm gonna start it off. There's my one right angle. Well, if it's a parallelogram, I know that let's see how good I can do this, that the opposite side, the opposite angle is gonna be the same. So now I'm building my parallelogram. So it has to be 90 and 90. And if it's a parallelogram, then I know the adjacent angles have to add up to 180. Well, to make this add up to 180, I need that to be 90. And same idea here. Okay, so knowing that just one angle is 90 is enough to know that it must be a rectangle. If a parallelogram has two adjacent sides congruent, meaning if I know this side and this side are the same, then it must be a rhombus. Okay, because if it's a parallelogram, then opposite sides are the same and we get all four sides. Not necessarily a square, could be a square, not necessarily. Okay, I'm gonna give us a break from notes in a minute, but I wanna fill this in. Our family tree, our ancestry.com tree. So if you flip this over, we're gonna make a little chart here. So this is how it works. Okay, so tree diagram. First we have quadrilaterals. Quadrilaterals are just a four-sided polygon. So it could be anything. 1, 2, 3, 4. It would look like this. 1, 2, 3, 4. Okay, we have our quadrilaterals. Sorry, I flipped the page and I'm on like the bottom underneath the rhombus. You zoom in a little bit because they can't really see it. I don't know which way is going to make it better. So we have our quadrilaterals. From our quadrilaterals, we get a parallelogram. Okay, there's other quadrilaterals that are not parallelograms, but parallelograms are one type of quadrilateral. Our parallelogram, our opposite sides are congruent and parallel. Our opposite angles are congruent. Our adjacent angles are supplementary or equal 180. And the diagonals bisect each other. Parallelogram. Opposite sides are congruent and parallel. Opposite angles are congruent. Adjacent angles equal 180. And the diagonals bisect each other. It's testing your art skills.
Oh,
Let me zoom it in onto the diagram. And the diagonals bisect each other. Parallelogram.
you have Hulu.
Hmm?
You have Hulu.
I do have Hulu.
Good.
I have Hulu, Netflix. Recently got HBO Max to watch the new Witches.
Oh,
I won't keep HBO Max then.
I'm really excited because Animaniacs is coming back on Hulu.
Oh, I didn't like that show.
No, I figured you
I
wouldn't.
don't like that show. I don't really like animation in general.
Oh, that's a blow to my heart. That's fine.
So there we have the beginning of our diagram here. We have our quadrilaterals and then our parallelograms. Now from that, parallelograms, we have special parallelograms. So we have our rectangle over here. We have our rhombus over here. We have rectangle and rhombus. Now, first thing I'm going to write here is that all of the above properties, right? Everything above is true. Plus the diagonals are congruent. Plus we have all 90-degree angles in the corners of our rectangle. Okay, everything up here plus this. These are the add-ins. I'll just draw my picture over here. So plus our, and I'm only going to show the things that are new. All of our diagonals are the same. I'll just draw another rectangle. And we have 90-degree angles. Okay, so plus these two things. Zoom that in.
So what did you watch?
Not a lot of TV. Well, I mean, I did, but not until I was like older. Not a home improvement. Used to love that show Dinosaurs. Has anyone ever seen the show Dinosaurs? It's probably so bad, but like my memory is that that was one of my favorite shows to watch.
I mean, I haven't watched them.
Yeah, that was a good one. A lot of Full House, Step by Step, Family Matters, Little Steve Urkel. Mm-hmm. Okay, so then we also have, just making sure this is an Essex Elementary School. We also have our rhombus, where our rhombus, it's still all above. All of the above. Everything up above, plus all sides congruent, plus the diagonals are perpendicular, which means 90-degree angles, plus the diagonals bisect the angles. Let me go through that visually. All of our sides are congruent. The diagonals are perpendicular, so I'm going to have diagonals that are perpendicular, all 90-degree angles in the middle.
The whole abbreviations.
I know.
Diagrams are per diagonal bisect.
Trying to cut down the writing.
I know.
So our diagonals, cutting these angles into equal parts. So now our family is grown. We have our rhombus and our rectangle. And the rhombus and the rectangle together give us our square. And now I'm just going to write this. All of the above. Okay, everything that's above, anything we just listed is going to be true for the square. Okay, all of the above. Not really, sometimes.
A lot of facts alike.
No, I'm not quite that old. I feel like I'm not, that wasn't really on when I was a kid.
Knight Rider,
Mm-mm.
She loves that show.
Star Trek.
No. My dad used to watch Star Trek
Oh my
sometimes.
gosh, that's all my dad is watching right now.
Yeah.
Whenever he came home, like off of work,
Oh,
Star Trek.
I was not a fan. All right. So now, before we move on, so we were supposed, that was insane that I even thought we were going to finish that yesterday. Now I want you to keep this tree diagram out, and I want you to go to the warm-up that we were supposed to do today first. Okay, and then if we have time, we'll do part 2. We may need to shift things around a little bit next week. Okay, you'll still be able to do the homework or most of it. Oh boy, this might be hard for those of you at home to see it. So in your warm-up packet, this was the warm-up we were supposed to do today because we were supposed to land there yesterday. This gives you a parallelogram, a rectangle, and a rhombus. And you have your beautiful diagram here. Okay, you're gonna put them side by side and see what you can do with solving for these pieces for each of these shapes, okay? I'm gonna pull up the document on the computer. And then we'll go over that. Let me, and so for this one, it tells us it's just a parallelogram, which means I only have, if I have my tree diagram, I only know like this is true. Okay, not anything below that is true. And what I do is I just kind of mark my diagram real quick. So I go through and I say, okay, my opposite sides are congruent. This is hard to see on there, I apologize. My diagonals are being bisected, so I'm just using a different color, so I don't have to use a ton of tick marks there, but I know that this is not the same length as this. I'm just using color coding here. And that my opposite angles are congruent. So many times I start with just labeling, like I know all of these things are true with this diagram. Okay, and now what I'm going to do is I'm going to go through and see, well, what does it give me? And can I figure out, given what I know about parallelograms, the other piece? So it tells me that EFG, E to F to G is here. It's this angle, EFG. That EFG is 70 degrees. And if EFG is 70 degrees, then what is the measurement of HEF? How am I supposed to know that? Does it give me any other information? EFE, what did I have from years past? Then HEF, am I reading that correctly? EFG, then H to E to F. But it's EF, oh, G's here. That, I was thinking this is G. Okay, nobody saw, I was like, what? That doesn't make any sense. I thought that was G, that's a Q or something, right? So EFG is this whole measurement is 70. Now I feel like we can find the other one. I just kind of, I thought it was only the half. I thought that was G. So EFG is the whole angle 70. And if the whole angle is 70, then this angle, which is adjacent to it, would be how many degrees? 110. Yeah, that's using the fact that these are supplementary. Woo! Scared myself for a minute. I was like, I don't know. So HEF would be 110 degrees. If EFH is 32 degrees, EFH, that is the small piece, right? And EFG is still 70. So now I wish I had labeled this differently. If EFH is, this small piece is 32 degrees, and the whole angle is still 70, it's asking for EHF, which is here. Okay, so let me zoom in on my diagram, or maybe even redraw it because it's so hard to see. If we knew this whole angle 70 and this piece is 32, it's asking us for this angle over here. So what it's using is alternate interior angle. So if this is 32, then that measure up above is 32 here, 32, 32. And if this whole angle is 70, then this whole angle is also 70. And so if I have 70 and 32, what's the other half of my angle? 38. Exactly. Okay, so it's using the other half of that 70-degree angle, but it's using alternate. So 32, 32, 38. This would also be 38 down here. Okay, alternate interior angles because our sides are parallel. The last one gives me part of the diagonal. I think I'm going to redraw. It's giving me that this length is 14 from H to Q, and it wants to know the whole length H to F, which would be how much?
28.
28. Good. Okay. On the next one, it's a rectangle. So I mark the special things for my rectangle. I go, okay, all of these would be the same. And all of my angles would be 90. Also, because it's a rectangle, I think we use this here. We know that if we have an isosceles triangle, then two of our angles are the same. That comes from ordering sides and ordering angles. So another thing that I know is because these two sides are the same, that this angle and this angle would be the same measurement. And then same on the top. Okay, so all four of those angles are going to be the same. That's the same triangle. And then on the other sides, these two sides are the same. So this angle and this angle are going to be the same. This angle and this angle will be the same. Okay, and that comes from this property. It's the same idea. If I order sides and angles, if I have two sides the same, then I have two angles the same. So then it tells us that EBC is here. If this angle measurement is 42, then what is EBA, which is here? Well, what do those two angles have to add up to? 90, I already marked it. This is a 90-degree angle. So if this is 42, this angle would be 48. 48. Okay. Then it goes to our diagonals. Now, I've already marked what's true about our diagonals. Our diagonals are all the same. So it tells me that AE is 7, and it wants us to find the other diagonal, which is DB. Well, if AE is 7, then 7, 7, not 7, not 7. What's the whole length of DB? 14. It's going to be two of those halves. Yes, exactly. Oop, what did I say? 14. I was going to write 17 for a minute. 14. Going back to our angles. EDC is 40. E to D to C is 40. So what is ECD? And we've already marked it. If this angle is 40, then this angle is 40. We've marked them as the same angle. That's using this. Okay, if sides, then angles. So if angle D is 40, then this angle C is 40. Okay, that's what we use there. If sides, then angles. Okay, and a rhombus. So I get to a rhombus, I mark what I know is true. All four sides are the same. These are perpendicular in the middle. And my angles have been bisected. So unlike the rectangle is different. On the rectangle, the angles that are the same are within each of these triangles. So I go, oh, those are the same, and those, and then these are the same, and so are these. In my rhombus, its opposite angles are being bisected. So it's boom, 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 boom. Which, by the way, is actually, I cover this half and look at this triangle, the same property we use in rectangles, right? Same side, same angles on that bigger triangle. Same here. Same side, same angles. And then going the other way, same side's going to give me same angles. Okay, so however you think about it, but the way the angles, the equal angles are broken down, it's different in a rectangle than it is a rhombus. Okay, so the first thing I do is I label it. And now I'm going to go through, and it tells me MN is 5. So what is NO? Which is there? 5. NO is 5. PMN. PMN is 35. So PML, which is here, would be 35. It's the other half there, and our angles are being bisected. So this would also be 35. And then it goes to MNO. MNO. Ooh, super tricky one. Okay. So then it goes to MNO. There's two ways that I can do it. One way that you could figure out what this is you could use the triangle here. And do you see that triangle? And I have 35 and 90, so I have 125 degrees. And so this half of that angle we're looking for, this half of this angle would be what? What did I say I had, 125? So 55 degrees. That's not our total answer though. And then if this is 55, the other half is 55, and the whole angle is 110. Okay, that's one way to get there. The other way to get there is to say I have 35 and 35, so I have 70 degrees here, and this whole angle and this angle are supplementary. So it's 110. There's kind of several ways I could think about getting there. One is using this triangle, then doubling it, because it's asking for the big angle. It's asking for M and O. It's asking for this whole angle, not just half of it. Okay, or using the fact that M and N are supplementary. So you should have 110 there. And then PON here is 42. This is a different problem, so I'm going to erase the other angle that I have there. Then PNO. Okay, so this stuff was separate, a separate question. So it's saying this is no longer true. If I know that that's 42, how would I find this angle here? And that would be using the triangle. So if I have 90 and 42, then I have 132 degrees. So this would be 48 degrees. Okay, it's changing the problem, giving you a new setup. Okay. Those are tricky. They're hard.
Okay.
So real quick, flip this over. There's a chart here. Watch this. Let's go through our properties one more time, and then you'll get some practice with this on homework over the weekend. In a parallelogram, are opposite sides congruent? Yeah. So a rectangle is a parallelogram, a rhombus is a parallelogram, a square is a parallelogram. We're going to hold off. We haven't talked trapezoids yet. Just put a line there. We're not going to talk about them today. In a parallelogram, are diagonals congruent? Are both diagonals the same length always? No. Which special one is that true for? Rectangle. Well, guess what? If it's true for a rectangle, it's true for a square, not necessarily a rhombus. Okay. The diagonals are being bisected. Is that true for the parallelogram? Yeah, it is, which means it's true for all of these. The opposite angles are congruent. Is that true for a parallelogram? So it must be true for all of them. The diagonals are bisecting the angles. What's that true for? Only if it is a rhombus, also a square. Consecutive angles or adjacent angles are supplementary. Is that true for our parallelogram? Yep, true for the big guy. It's true for all of them. The angles are all right angles. Is that always true for a parallelogram? No, but it's always true for a rectangle and a square. The opposite sides are parallel, so it's true for a parallelogram. Yep.
That's it, it's name.
Parallelogram. All sides are congruent. All sides are congruent. No, that's a rhombus
And a square.
and a square. The diagonals are perpendicular, only true if it is a rhombus. Then it's true for a square. We're not going to talk about this one right now. Okay, so just a different way to look at it. Okay, these are all the things that could be true. Okay, only 5 of them are true for all of them. Okay, and then if I get to my rectangle, more things are true. My square, every darn thing, right? So every single thing listed there, I check the square box for. Just again, different way to look at it. So what you're going to do is just one page of homework. You're going to, again, kind of fill out something similar here. Answer some are true, false. These are a little, you got to think. And then a rectangle, a rhombus, and a square. Like I said, what I would do is I'd just solve what I can, gives me one angle, and then I'd fill in the blanks. Okay?